Okay, excuse me. Let's have a look here. Basically show that the integration should be 0. All right, so here we'll go with u equals cos 2 theta, because that will mean du will equal minus 2 sine 2 theta d theta. So then the integration becomes 0 to pi. Well, that's with the u value, the theta value, so I'll just leave that for a moment. U squared minus 2 du. Okay. Now, the limits we can change. These were in terms of t. Well, actually, let's just integrate it. So that becomes minus 2u cubed over 2, and then 0 to pi. So cos 2 pi is cos 0, which is 1. So it's minus 1 minus minus 1, which is indeed 0. Here we'll say u is cos t squared. So that means du equals minus 2t sine t dt. So the integration, the t, sorry, lost my square there. The t and the sine t squared dt. You know, I feel like that should have been a half, not 2 in the previous one, because I need to divide by 2 here. So actually that should have been 1 over 2. Just like here, it'll be minus 1 over 2. You're left with t sine t squared dt. So that would be u du. So that would be minus a half u squared over 2. So that's minus a half cos squared t squared over 2, 0 to root pi. So root pi squared is pi. Cos of pi is minus 1, squared is 1. So that's minus a half times, or I can take the 2 out, minus a quarter, 1 minus cos 0, which is 1. So that's equal to 0 as well. Here, actually, what's the point in the substitution here? What's even the point? I don't get it. All right, whatever. U equals 1 minus 2t. So that means du equals minus 2 dt. So then the integration becomes minus 1 over 2. Du. So that would be minus a half u, which is 1 minus sorry, u's there, and that becomes minus a half u squared over 2. So that's minus a quarter 1 minus 2t squared. 0 and 1, so that's minus a quarter. If I put in 1, I get 1 minus 1, and I've put in 0, I also get 1. So that's equal to 0. Okay. This one here. U equals Do I want to say t minus a half? Do I want to say the whole thing? If I take out a half minus a half, then if I divide by minus 2, I'll be left with t minus a half on the top. So I'm thinking I want to say u equals t minus a half, and that means du equals dt. So this becomes the integration of minus a half u over 1 plus u squared du. Now, if I say v equals 1 plus u squared, then I'll get dv equals 2u du. So a half dv equals u du. So then this becomes minus a quarter dv over v. Right. So that would be minus a quarter log v. But v is 1 plus u squared. But u is t minus a half. 0, 1. So that would be minus a quarter. 1 minus a half is a half. Squared is a quarter. So that's log 5 quarters. And then if I put in 0, I get a half minus a half squared is a quarter. Yeah, log 5 quarters minus log 5 quarters, which equals 0. Whew. Okay, next one here. Do I want to say if I could go with u equals t minus pi over 2. So this becomes the integration of sine u cubed cos u du, because du equals dt. But don't quite see what substitution to use next, unless I change this into the integration of sine u. No, the cube is just on the u, actually. It really limits what I can do here. Maybe I can't actually integrate this one. Maybe I have to show it's 0 because that it's an odd integration. When t is 0, u is minus pi over 2. And then when it's pi over 2. So this would be in the form of integrating from minus a to a. That's an odd function. That's an odd function. So that's an odd function times an even function, which is the integration of an odd function, which would be 0. So I think they might actually want us to do something like that for the previous questions, but it's not really necessary to use substitution in that case. But it kind of is helpful here to change the variable. So Okay, here, maybe it's something similar. If I say u equals 1 minus t, then this becomes the integration when t is 0, that's 1. And when it's 2, it's minus 1. Interesting. And that would be u cos pi t. Oh, no, maybe it'd be better to use the substitution pi t, perhaps. U equals pi t. So this becomes integration from 0, not from 0, yeah, 0 to 2 pi, 1 minus t, 1 minus t, which is u over pi, cos u dt, and du equals pi dt, so that's 1 over pi du. Du equals pi dt. So my problem is that it's not over the right. I kind of don't quite like the interval. So let me think again here. What about t minus 1? Then the integration when t is 0, u is minus 1, and then when t is 2, that's 1. I think that would be better. And then 1 minus t, that becomes minus u. And then that's cos of pi t. So that would be t is u plus 1. So that's u plus 1 times pi. And then du equals dt. So that's an odd function for sure. But what about this one here? I might have to examine what happens here a bit more. So if we use the trig rule, this is cos A, cos A, cos B, minus sine A, sine B. Sine pi is 0, so that's actually gone. And cos pi is minus 1, so that actually goes with that. So you're just left with the integration from minus 1 to 1 of u cos pi u du. And that is an odd function by an even function. So that's the integration of an odd function from a symmetric interval. So that's 0 for sure then. Okay, doing okay with these. Hopefully I am. And then this last one here, u equals sine t. So that means du equals cos t dt. So then the integration will be pi over 4, 3 pi over 4, sine squared, that's u squared, and then cos t dt du, that's u cubed over 3. So that's sine cubed t over 3, 3/4 pi, and 1/4 pi. So that would be 1/3. And then sine of 3 pi over 4 cubed is root 2 over 4. And then 1/4 cubed is thankfully the same thing. And that's 0. Okay, that's up to 3, 1, 2 done.